statements that I make that about things that you guys should be familiar with, especially in the first section. The first section is just your Cartesian coordinate system. Now, you might not remember that terminology, but I assure you it'll come back very quickly. Your Cartesian coordinate system is how you graph things in 2 dimensions. Okay? We have a horizontal axis we call our x-axis. These are for our independent variables. And we have a vertical axis called our y-axis. That's for our dependent variables. I think you'll grant me that these 2 perpendicular lines divide this space into 4 different regions. These regions have names. I'm only telling you this so that you know that when I use it. This is called quadrant 1. This is called quadrant 2. This is called quadrant 3. And this is called quadrant 4. In mathematics, we always go counterclockwise. And it really upsets my family because when we play cards like cribbage at home, I always deal counterclockwise because it's just the way I work. Anyway, side note. So, there are some special things in this system, okay? You can think of your x-axis as sort of like the real number line. Here's 0, and then as we move to the right, our numbers get bigger in an infinite direction, and as we move to the left, our numbers get smaller in an infinite direction. Our y-axis, again, we start out at 0. Now use your intuition, you guys. As we go up, what do our numbers do? They go up. So 1, 2, 3, 4, etc. And as we go down, our numbers get smaller. When we graph things on our Cartesian coordinate system, we graph them in what we call ordered pairs. In other words, the order in which you write the number matters. You always put your x value first and your y value second. You with me this far? Sweet. So this middle guy, he's my ordered pair 0, 0. He's so special. He's called our origin. Now, what is section 1.1 about? It's all about can you plot points. So when I tell you that your first quiz is about the easiest, or your quiz this Thursday is about the easiest quiz you're going to take, I'm going to ask you to plot and label 5 points because I'm at a loss as to what else to quiz you on this week. Okay? So let's go through a few of them, but it's kind of a feel-good type thing before, woo, spring break, right? All right. So, what if, and then I have 2 definitions to give you, and then we'll move into our next section. What if I want you to plot the point 2, 3? Well, what you do is you go over to where x is 2, so you go right 2, and then you go up to 3, and lo and behold, you have it. You guys all okay? What if we want to plot the point -1, -3? Now what do? You start here, and what's the first thing you do? You go left 1, and then what do? You go down 3. How's that? What if I want you to plot the point -3, 0? What do now? You go which way from here? Okay, well, you first go to your x value. Your x value is -3. And then, since my y value is 0, do I move up or down? No, I stay put. Guys with me there? On the other hand, what if I've got my ordered pair 0, 4? Now my x value is 0, so do I move to the right or to the left? No, I stay put, but then what do I have to do? I have to scooch up 4. Are you guys okay plotting points? Does anyone want to see one more? All right, let me do this. I need to tell you 2 interesting definitions, and these are some things that we are going to come back to, and don't worry, I'll refer back to this. But I need to tell you what your definition of an X-intercept and what your definition of a Y-intercept is. Because later on, we're going to be using these things in order to do a lot of our graphing. Okay? By definition, your X-intercept is where your graph touches or crosses your x-axis. Isn't this sweet relief? All right, so let's talk about our x-axis. Here's our x-axis. Wow, x can take on infinitely many values along here, can't it? But I claim something is always the case wherever you are on your x-axis. Hint, have I moved up or down? No, I stayed put. And therefore, what is y always equal to? 0. Good. So, being pragmatic, we'll say to find it, what you do is you set y equal to 0 and solve for x. My point is, no pun intended, any x-intercept will have the form x comma 0. Is that okay? Cool. Your y-intercept, by definition, is where the graph touches or crosses your y-axis. Again, we should be pragmatic and ask ourselves, what's always the case with being on our y-axis? Well, do you guys agree now your y values can take on infinitely many points? But have I moved to the right or to the left when I live on my y-axis? No. So what is always true no matter where I am on my y-axis? X is always 0. So to find this, what you do is you set x equal to 0 and solve for y. In other words, your y-intercepts are of the form 0y. Now, I don't know how much you guys remember about lines, but y-intercepts are pretty big things when we deal with lines. So, how'd you like section 1.1? Pretty nice. Okay, now let's get a little more interesting. Your homework for that section is literally plot points. Now we're going to start talking about lines. Now, when we talk about lines, I'm going to guide you through a whole bunch of different things here. Okay, we're first going to talk about slope. We're going to talk about finding patterns with the natures of slopes. Okay, we're going to start talking about finding equations of lines and graphing them. On Wednesday, I'll finish up this section, but on Wednesday, what we'll do is we'll find equations of parallel lines, perpendicular lines, horizontal lines, vertical lines, and then, of course, we get to start in on our fun word problems. All right, so what I would like to do first off, before I start with the slopes, is tell you this. I know that you can find the equations of lines a couple different ways. I'm going to show you both ways, but when I ask you to find the equation of a line on any test or quiz, I don't care which method you use. You got to use whichever method jives better in your brain. Okay? I have my preferred method, and most people have theirs, which is using y equals mx plus b. That may or may not ring a bell, depending on how long ago it's been for you. Okay? But my thing to start out with is the following. We live in this beautiful state of Montana. And living in Montana, if you like to hike or you like to bike or anything like that, you're very conscious of slopes. Yeah? I mean, it is a whole different thing biking up this hill as opposed to biking up that hill. All right? Now, one thing I need to point out, in mathematics, when we're talking about our graphs, we always read them from left to right. Okay? So, let me make a comment about the slope and what we're actually measuring. Let's talk about what happens as we travel this horizontal distance from x1 to x2. With this first line, do you guys agree, as I travel from x1 to x2, there is a change in my vertical distance? It's not a whole heck of a lot, but it certainly exists. You all agree? Okay? On the other hand, now let's look at our other line. As I move that same horizontal distance, isn't my vertical distance changing a heck of a lot more? Absolutely. All right? So, when we're talking about slopes, what we're doing is we're essentially saying, hey, as we travel a certain distance horizontally, what's happening to the change in my vertical distance? Okay? Well, I think you'll grant me that if I want to talk about the distance between these points, isn't that x2 minus x1? Think of it this way. This whole thing is x2, isn't it? But we're not interested in this distance, and that distance is x1. And that's why this distance right here is x2 minus x1. Similarly, let's talk this guy, because he's cooler. y2 here and y1 here. I claim this vertical distance is y2 minus y1. Why is that the case? Well, this whole vertical distance is y2, isn't it? But we're not interested in this part of it, are we? But what is this vertical distance? y1. That's why we subtract it off. So, that tells us the following formula for our slope. This formula will be given to you when you need it. If you have two ordered pairs, your slope is your change in your y values over the change in your x values. You guys have probably learned it somewhere along the line as rise over run. Now, you could have y1 minus y2 in your numerator, but then in your denominator, you better have x1 minus x2. Okay? So my point is this. It doesn't matter which y value you start with, but whatever y value you put first, his corresponding x value also has to go first. Okay? So, what I want us to do right now is practice finding some slopes. In fact, we're going to find the slopes of 4 different lines. Okay? And what we want to do is come out with some patterns. Okay? And so, for example, what if I want you to find the slope of the line containing -3, 5, and -4, -3? All right, so let's write it out. It doesn't matter in my numerator whether I start with this -3 or whether I start with this 5. What do you guys want to start with? -3. Okay, so I'll start with this -3. So it's -3 minus 5. And since I started with this y value in my numerator, I start with that x value in my denominator. You okay this far? All right, -3 minus 5, will you guys agree is -8? And remember, minus a negative is plus a positive, so that's over -1, and therefore you get 8. Oh my gosh, what does a line with slope 8 look like? It is steep. Check it out. Do you guys like riding your bikes? As a hobby, I do a lot of bike touring, and we once did this wonderful loop where every day we did at least one pass. It makes you really bummed when you pack a lot of granola because you're puffing it up the hill. All right, so there's -3, 5, and then there's -4, -3. Wow! Super duper steep, isn't it? Here's the point I want to make. When you have a positive slope, as you move from left to right, your line goes up. Whew. So, next guy. Don't worry, we'll start finding equations of lines today too. I'm sure you are all really worried. 8, -1, and 4, 3. Can we find the slope of this line? Totally. Again, it's the change in y value, so 3 minus a -1, over the change in x values, so over 4 minus 8. Do you all agree you get a 4 in your numerator and a -4 in your denominator? So isn't that equal to -1? Oh, here's a negative slope. Well, what we can do is plot the points. Here's 8, -1, and here's 4, 3. Then we get to play connect the dots. And notice, with a negative slope, as we move from left to right, our line goes down. How's this going so far? Are you having a ball? I can tell. All right. Next, what if I want you to find the slope of the line containing 2, 4 and -1, 4? All right. Again, your slope is your change in y values over the change in x values. What do you get in your numerator? This is not a rhetorical question. 0. What do you get in your denominator? -3. What's 0 divided by -3? 0. All right, you guys, use your intuition. Suppose I told you you are going on a walk, on a sidewalk, that has no slope, right? 0 slope. Can you describe it to me? Totally flat, okay? So, if we plot both of these points and then play connect the dots, notice, in fact, we do get a horizontal line. All right. What if I want you to find the slope of the line containing these points? Last slope for now. Again, isn't it our change in y values over the change in x values? What do we get in our numerator? 3. What do we get in our denominator? 0. What is any number divided by 0? Undefined. It's illegal to divide by 0. The math cops will come and take you away. Okay? Why? Do you want to see? Of course you do. You guys, isn't defined as the inverse of multiplication? Yeah, for example, 12 divided by 4 is equal to some number, so that 4 times that number gives you 12. What is that number here? 3. So 12 divided by 4 is 3, since 4 times 3 is 12. What is 36 divided by 2 equal to? 18. Why? Since 2 times 18 is 36. So, what is 3 divided by 0? Well, it's equal to some number x, so that 0 times x gives you 3. But is there any number that you can multiply by 0 and get a non-zero number? No, no number exists. That's why it's undefined. Cool, huh? I always like knowing why. All right, so now that we've said that we have such a thing as an undefined slope, why don't we plot the points and play connect the dots and see what that looks like? Well, 1, 4, 1, 7, yeah. We have a vertical line. So when you have an undefined slope, you have a vertical line. Guys with me? Okay, so you guys have enough practice with slopes? At least for now? All right, watch this. You don't have to write this part down yet. Do you guys agree what I did is I wrote my slope formula again? It looks a little different, right? What looks different? Well, normally I have my m on my left and my fraction on my right. But it's okay to write it like this. Do you guys also agree the other differences is I don't have my subscripts y2 and x2? But it's still the formula for our slope, change in y values over change in x values. Okay? Why did I write that? Hold on. So, what if I said, oh my goodness, I would love to rewrite my slope formula, but I don't feel like having a denominator. I want to get rid of my fraction. Okay? Think about algebra. How do you get rid of denominators in a legal manner? Can't you multiply both sides by your denominator? On our right side, it doesn't look pretty, but it's okay. We have m times the quantity x minus x1. And on our left, do you guys agree we have x minus x1 in our numerator, in our denominator? They cancel off, and so we're just left with y minus y1. All right. Yeah?
Is this the second way of doing it?
Of doing what? Finding an equation of a line. Okay? Now, a lot of you guys, I'm not going to talk about it until Wednesday. A lot of you guys, when you find the equations of lines, you use y equals mx plus b. Am I correct? Okay, at least those of you guys who remember finding equations of lines. Another way you can find the equation of a line is this. This is called the point-slope formula for a line. I showed you where it came from because I wanted to motivate it, okay? Literally, all it is a rewritten version of my slope. But this is a very useful way to find the equation of a line. I'm going to show you how to do it this way, and on Wednesday I'll show you the other way. You can pick whichever jives better for you. I like using this guy, okay? Now, let me take a couple of examples. What if I want you, using this, to find the equation of the line with the slope equal to 2, passing through how about -1, 1? here is I want to graph this line, okay? Because when you're just given a point and a slope, you can always graph it. When you do that, you always start with the point. So, do you agree I'm starting with the ordered pair -1, 1? Any questions how I plotted it? Okay, now, do you guys agree my slope is 2? And do you agree that can be written as 2 over 1? And my slope is rise over run. It's a nice little jingle, right? 2 over 1 is rise over run. All right, well, what does that mean? It means you start at that point and you rise 2 and you run 1. So, do you guys agree what I do is go up 2 and over 1? I have another point, and again, I can play connect the dots. What's this point called? That's called my Y-intercept. That's where my graph crosses my Y-axis. Guys with me here? What is our Y-intercept in this case? Right on. All right, now let's find the equation of the line. And I know if you remember your y equals mx plus b, you already know what it is, but check it out. Okay? How do you use this formula? You plug your ordered pair in for x1 and y1, and you plug your slope in for m. Watch. Ready? Y minus my y value. What's my y value over there, guys? 1 equals m. What is my slope here? 2 times x minus my x value. Y'all with me this far? So, I'm going to first clean up my parentheses. Minus a negative is plus a positive. You with me there? Cool. All right. My next step is to use my distributive property. Don't know how long it's been since you guys have done mathematics, but when you have a number times the sum or difference in the parentheses, you distribute your 2. Everybody in your parentheses gets to enjoy your 2. So you have y minus 1 is 2x plus 2 times 1, which is 2. Last but not least, we always like these things solved for y. How do you move this minus 1 over? You add it to both sides. So do you agree we get y equals 2x plus 3? Now, yes, we already knew that because we graphed it, but there's a cute little connection that some of you might not remember. Oh boy, given the statement of this problem, have I seen a 2 anywhere? Yes, my slope. Given the fact that I wanted to graph this problem, do I see a 3 anywhere? Yes, my Y-intercept. You guys remember that? Maybe? Cool. All right, let's do another guy. What if now I want you to find the equation of the line, and I always do PQN for equation of the line. What we're going to do for this line is we're going to find the equation and then we're going to graph it. Okay? Let's find the equation of the line with the slope of negative 2/3. And let's pretend that it's passing through, I don't know, 9, I don't know, what do you want it to pass through? 5. Me too. All right. Using the formula y minus y1 equals m times x minus x1, I'm going to say y minus my y value. What's my y value? Let's make it a negative 5, sorry. We got to liven this guy up a little bit. Y minus negative 5, you with me there? Times m, what's m? are beautiful. You can't bake banana bread if you don't have fractions, right? All right, minus a negative is plus a positive. What do I do to my 2/3? I distribute him. Negative 2/3 times x is negative 2/3 x. What's a negative times a negative? Positive. I won't normally spend time like this, but watch you guys. If you're taking 2/3 times 9, and that's the same as 9/1. And yeah, you could multiply your numerators and multiply your denominators and simplify, but I prefer to say 3 goes into 9 3 times, and 2 times 3 is 6. Next, subtract 5 from both sides. So don't you have negative 2/3 x plus 1? And that's the equation of your line. Are there questions on this? Let's graph him. So, let me ask you a question. Doesn't matter. Should we graph him using our slope and this point that it passed through? Or should we graph it using our knowledge here? Let's use the point. You know why? We'll get there. If we go backwards, but watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5. Not drawn to scale. That's why I told you you don't need graph paper here. All right. Equivalently, if you wanted to start it at your y-intercept of 1, I claim you're going to get the same thing. What I want to focus on here is, notice my slope is negative 2/3. Negative 2/3 is our slope, and therefore, isn't that our rise over run? What does it mean to rise a negative number? What do we do? You go down, all right? So what this says is go down 2 and over 3, and then connect your dots. And if we continued it, I swear it would go through your 1. If for no other reason, I'm going to make it so. But again, you could start here and go down 2 and over 3. You go down 1, 2, and over 3, and again, connect your dots. Are you guys okay with this stuff? All right then. Huh? Because I remembered that when you're in the form y equals mx plus b, the number in front of x is always your slope. If you don't remember it, don't worry. And b is always your y-intercept.